All right, so we've all seen what happens when AI gets really, really good at language, right? I mean, look at ChatGPT. But what's the next big step? What happens when AI moves beyond our screens and starts to actually understand and, interact with the physical world? Well, that is the next frontier. It's called physical AI, and today we're going to dive right into the race to build it. And you don't have to take my word for it. Just listen to this quote from Sonia Fidler, who's the VP of AI research over at NVIDIA. She says, "The physical AI is the frontier." I mean, that says it all, doesn't it? This is the new edge. This is where all the exciting stuff is happening in AI development. So, this naturally leads to a huge question that's like buzzing all over the tech world right now. Is the transformer, the engine that powers things like ChatGPT, is that it? Is that the end game for AI? It's been so unbelievably revolutionary. It's easy to think so, but what if it's not the final answer? What if it's just the engine for something way, way bigger? Okay, so to really dig into that question, we've got to clear up a few things first. There's a ton of jargon flying around, transformers, world models. So let's just pause for a second and make sure we're all on the same page about how these pieces actually fit together. Yeah, one of the biggest points of confusion I see is people thinking that new ideas like so-called world models are supposed to replace things like transformers. But that's not it at all. They're not rivals. The easiest way to think about it is like this. The architecture, that's your transformer. That's the engine. The task, like building a world model, that's the job you give that engine to do. See the difference? So the key takeaway here is that these things absolutely work together. They're not mutually exclusive. Just as Sanja Fidler points out, there's no conflict here. You can totally use a super powerful transformer architecture as the engine to power the task of creating a world model. It's not an either-or debate at all. All right, so we've cleared that up. Transformers are the engine, not the whole car. But that still leaves the question, what exactly is a world model? And what's this spatial intelligence thing that all the researchers are so obsessed with? Let's break these big ideas down. So, a world model, think of it like an AI that builds its very own internal simulation of the real world. It's almost like the AI has its own physics-based imagination. It can try out an action inside its own virtual world, say, a car turning a sharp corner, and then it can predict with incredible accuracy what's going to happen next. It's basically a flight simulator for reality itself. How cool is that? And that's where the next piece of the puzzle comes in: spatial intelligence. This is the magic ingredient that gives an AI a real sense that it exists in a 3D world. It's the huge leap from just processing text on a screen to actually understanding things like depth, physical objects, and how they relate to each other in space. And you can imagine, for a robot trying to get through a messy room or a self-driving car on a busy street, this is absolutely non-negotiable. Okay, I know this all might be sounding a little abstract and out there, so let's make it real. Let's look at a concrete and honestly a pretty mind-blowing example of how NVIDIA is putting these very ideas into practice right now. To really get just how big of a deal this is, you gotta look at how we used to do this stuff. Take training self-driving cars. In the past, you'd have human artists literally spending months just to build one single virtual intersection. Then we got a bit smarter and used AI to reconstruct real-world data, which was faster, but you couldn't really change anything. Now, now we have the future. Generative simulators like NVIDIA's Alpha Dreams. This thing can generate an entire fully interactive driving world instantly, just from raw data. And Sanya Fidler has the perfect way to describe it. She says, it's really kind of like a game engine. It's just that the entire software is written by these models. Think about that for a second. It's like a video game world, but the entire thing, the physics, the other cars, the weather, it's all being written and rewritten by an AI on the fly. A world that literally builds itself. That's the leap we're talking about. So you can see the potential here is just staggering. Which begs the question, what's stopping us from having physical AI everywhere, right now? Let's get into the major hurdles that researchers are trying to clear as we speak. Right now, the research is really zeroed in on a few key challenges. First, they want the AI to learn physics all on its own, without having to lean on old-school physics engines. They're also adding more senses, so the AI can hear an ambulance before it sees it, for example. And of course, for robotics, the huge one is solving for touch and physical interaction. But honestly, the biggest challenge, the one that towers over all the others, is data. And this right here is the absolute heart of the problem. As Fidler says, the upper bound is data. and AI can only learn from what it sees. Now, the internet gave us a gift, trillions of words and pictures. That's all passive data. But physical data, the feeling of friction, the amount of force you need to pick up a box, the way a cushion squishes when you press on it, that's active data. It requires physically interacting with the world, and collecting that kind of data at scale is just exponentially harder. Okay, so we've got these massive challenges, especially with data. So what does that mean for us? What's the real timeline here? When can we actually expect to see this stuff become a part of our daily lives? So let's break it down. Where are we going to see that first ChatGPT moment for physical AI? Well, for autonomous driving, it's actually looking pretty close. We're talking maybe less than 5 years. Why? Because you can gather just massive amounts of data from all the cars that are already out there driving around. But for general-purpose robots, the kind that might help around the house, the limitations of the hardware and that huge data bottleneck we talked about, well, that pushes the timeline further out. We're probably looking at more than 5 years for that. And that brings us to the final thought I want to leave you with. We've already seen how an AI that understands our language can completely reshape our digital world. So the real question is, what happens when AI understands not just what we say, but the physical world we all actually live in?